Okay, a little quick update. This is my actually charge controller at the moment. As you can see, it's actually on sort of fully charged. I've charged my battery bank up with it, and my amp meter at the minute is actually running about 10-11 amps. This is on a winter's day in January, which isn't bad if you think about the power I'm getting from it, which is 240 watts is going into the actual dump load, which I'll show you in just a second. Just a quick explanation of what these figures all mean. Could be quite useful to other people, you see. Well, on the left at the top we got amps, which are being dropped into the dump load. The actual panels, which are run at 24 volts, this system's at 24, is putting out 240 watts ish into the dump load at the moment. The voltage has actually is now dropped down to 26.8 because the batteries are fully charged. I've actually plugged in something else to this as well. This is what this cable is down here. I'll go a little closer. This is actually a battery temperature sensor. It makes a big difference if it's in the winter time. It actually, what it does, and if it drops a certain temperature in cold, it increases the voltage up slightly to compensate for the cold of the batteries. It's very important completely. I'll go back to this quick. On the right hand side at the bottom you can see there's actually 330 kilowatt amp hours been produced by the panel since I've had it up as it is. And on the left, today so far it's actually made 19.5 kilowatt amp hours, which is doing pretty well. And obviously 10 amps is a good hit in this weather, especially this time of year. This charge controller is very, very important to look after the batteries. I can't stress how important that is. But the voltage will go up and down. If it gets really hot, the voltage at the end there on the right hand side, it goes up in the winter time and it'll go slightly down in the summertime for the batteries to get hot. Thought I'd better just explain that. It's a very important bit for all you people who are just learning all this stuff. This is all good fun. Hopefully I'll have my system up and running one day. That'll be really good to, and maybe if I make it good enough, I can sell it or produce it for other people, which is what I'm going to try and do. Thanks for listening. Okay, back to normal focus. I had to change focus on the camera because it wouldn't do macro. Since I've actually spoken to you, sort of all of you, as you can see, my batteries are now actually wired with some extremely thick cable. Got a little bit of the truck in this garage, but that's hard luck. This is my dump load. It's a 1000 watt Future Energy dump load. I actually got it for £92 because the VAT dropped. I got it slightly cheaper. I decided to go to that instead of water because it's a lot less messy, and I can also bolt this on the wall later on once I get all the wiring sorted out on this system. My ideal situation is to have the solar and wind running, and the idea is to have energy power on all my main equipment except ovens and things like that, if you've got ovens, during the whole evening time, so it'll automatically switch over from about 6 o'clock and then start powering from the batteries, which is quite capable of doing, because I've got a 1000 watt inverter sitting here, which is going to be going through this as well. You might see this thing. It's a brand new meter to calibrate in kilowatts, so I can see how many kilowatts I'm producing. Okay. As you can, I'll just show you. I've got another bank of batteries under here. There's a total of, I should think, there's 30 in here now. 30 batteries, and they're all wired with really thick cable. The type of cable I'm using is this sort of thing. As you can see, it's nearly as thick as my finger. It's about 20mm, 25mm multi-strand cable. Originally I got 20 meters of it, and it cost me 50 quid, which is a good deal on cable.